So what we're going to do now is we're going to look at another type of discrete probability distribution, which is the Poisson probability distribution. So the Poisson probability distribution gives probability of the number of occurrences over a period of time or space. Now to find probability of the number of occurrences over a period of time or space, we use the following formula. So the probability that x is equal to x sub k is mu to the x sub k power times e to the negative mu divided by x sub k factorial, where we have e is what's known as the Euler's number, right, which is approximately 2.71828 and so on, right? In your calculator there should be a button for this number, so you don't have to memorize the 2.71 value. Then we have mu, which is the mean number of occurrences in a particular interval. And then x here is the variable that denote the number of occurrences over a period of time or space. Okay, and it is known as the Poisson random variable. Okay, so the idea behind this formula is that given a value of the given the mean number of occurrences, we can go ahead and calculate the probability that we have 0 occurrences, 1 occurrence, 2 occurrences, 3 occurrences, and so on and so forth. So let's look at an example. We may use the Poisson probability distribution to compute the probability of the number of customers arriving at a restaurant. In let's say an hour, right? So here we have the number of occurrences, which is the number of customers arriving at the restaurant, right, over a period of time or space. Here the period of time in question is an hour. So now let's say that if I let x be the number of customers, then let's think about what are the possible values of this variable x. So think about a restaurant, right? In any given hour, there's a possibility that nobody shows up. Okay? So there may be 0 is a possible value, right? You may have one person who shows up, you may have 2 people, you may have 3 people, right? And so on. You may have 50 people, right? You may have 100 people. You may have 1,000 people show up in an hour. It's unlikely, but it's not impossible, right? And so on. So in fact, you can have as many people show up in an hour as you want, right? The larger the number, the less likely it's gonna be, but it's not impossible, right? So it's not impossible for us to have 1,000 people all of a sudden show up at a restaurant in an hour. And so for a Poisson random variable, so for a Poisson random variable, the number of possible values of x right, is infinity. So you can have a lot of possible values, right? For example, here I listed 1, 2, 3, 4, 5, 6, 7. I listed 7 possible values, but in fact you can have the number of possible values can be extremely large. Okay? So if you can, let's say you want to construct a probability distribution for a Poisson random variable, you're gonna have x, and then you have the probability that x is equal to x sub k, right? So for x, you may have 0, 1, 2, 50, 1,000, and so on, right? Associated with each of these numbers is a probability. So the probability that x is 0, the probability that x is 1, the probability that x is 2, and so on and so forth. And to find these probabilities, we use the formula from up here. The formula we talked about earlier. Now looking at this this probability distribution, what you should take away from this is, again, the number of possible values is very large, and also there's not a maximum value, right? So there is not a maximum value for a Poisson random variable. Okay. Note that this is different from the binomial random variable, right? right? In the binomial random variable, we have a maximum value for the binomial random variable, which is n, right? The number of trials in the corresponding binomial experiment. Here in the Poisson, there's not a maximum value. Okay. So in this video, we talked about the Poisson probability distribution. We gave a formula that we can use to find the probability that a Poisson variable takes on a particular value. And then we talked about the fact that the number of possible values for a Poisson random variable can be infinity, so it can be extremely large, and there's not a maximum value for the Poisson random variable. So there's not a maximum value that the variable can take on.